Welcome to Easy Math TV. We're going to continue our statistics series, and this is introducing you to a new topic. The new topic is continuous random variables. It's part of the overall topic of just distributions of random variables. So prior to this, we talked about discrete random variables, and that's probably the area that most students, most people are most familiar with. We are most familiar with the discrete random variables because it's very easy to just create a histogram and understand how to calculate probabilities with them. And we tend to avoid continuous random variables because a lot of times it just, quite frankly, requires calculus to be able to handle continuous random variables. But there is a way to just understand the concept of a continuous random variable without mentioning any calculus formulas. So that's what we're going to do here. I'm going to have to split this into two videos. So this is part one. And let's just define what a continuous random variable is and talk about like what it is that we need. What do we need about continuous random variables in order to be able to answer questions with them? So let's let x be a random variable that takes on any value from 1, starting at 1. So it literally just stops there, like it doesn't continue on to the left of 1 and on to positive infinity. So the values of x could get as large as possible. In other words, we use the interval notation, which with a left bracket and a 1, and then a comma infinity, and then a parenthesis. So that bracket 1 comma infinity shows you what the range of values of x is. Okay, they can take on any value from 1 to 12 to 500. Okay, and that describes all of our possible outcomes, little x, for our random variable capital X. Unlike discrete random variables, we do not define the probability for individual outcomes. So you will notice here there is no column for capital P of X. There's no column for that. What we do have a column for, however, is the cumulative probabilities. That is the critical piece of information that we're going to need. And the reason for that is because cumulative probabilities are associated with areas of the region under the curve. Area under the curve. Okay? So the first thing that you need to understand is that little f of x is called a probability density function. So the column here for column B is little f of x. When you see little f of x, we're talking about a probability density function. And its purpose in life is to show you which values are actually more likely, which values are less likely. So the higher the y value, the taller little f of x is, the more likely those outcomes are. The shorter it gets, like, so, as you move along here, it gets shorter and shorter and shorter, almost down to 0. So those are going to be less likely, a lot less likely to occur. So the purpose in life for little f of x is to just show you, visualize, which values of x have greater likelihood and which ones have less likelihood. Okay? Then when we actually calculate the probabilities, we're going to be using these cumulative probabilities to calculate those. All right. So we're going to illustrate this concept of a continuous random variable with something that I'm calling capital X be, let capital X represent the lifespan in years of a certain can opener after 1 year. So this is just can openers that have already lasted for 1 year. All right. We've eliminated the ones that broke within the first year. This is just the population is can openers that have already made it to their 1 year point. and what is their total lifespan going to be after that point. All right. So little x, the little x values are in column A, and we start with 1 and we can increment it by any amount you want, but these are the x values that I chose for graphing purposes. So start with x equals 1, then x equals 2, 3, 4, 5, 6, and then I skipped 7 for some reason. I went to 8, and then 10, and then 50. Okay? So I started with those. That's a good solid set of numbers to do your graph, to make your graph. And then in column B, these are our little f of x. And little f of x is, to just tell you, the formula for it is 1 divided by x squared. So that's how I calculated all of these. It's 1 over x squared. But you don't need that. Like, we can just type in these numbers. So the value for f of 1 is just 1. The value for f of 2 is 0.25. The value for f of 3 is a repeating decimal, 0.1111, but it's actually equal to 1/9. F of 4 is 0.0625. F of 5 is 0.04. F of 6 is another repeating decimal, so that's 1 divided by 36. F of 8 is another repeating decimal, so that is 1 divided by 64. F of 9 is 0.01. And, sorry, F of 10 is 0.01. And F of 50, because I went all the way out to 50, I was curious what the actual little f value would be for that, and it's 0.0004. So make sure you have enough zeros on that decimal. It's 0.0004. Okay? It is important, very important to note that these values that you see here in column B are not probabilities. They are not probabilities. They are related to it in some way, but they are not the actual probabilities that we're going to be calculating. Okay? All right, so there's only a couple of other things we can talk about before we stop this video and move on, and then move to part 2. So I just want to point out one row here for x equals 5, and little f of x is 0.04. And, what do we mean by this cumulative probability thing? So over here, I've made a picture. I've actually drawn the shape of the cumulative probability at x equals 5. So as you can see, it starts at x equals 1 and literally just hits a wall there. It just like a cliff. It just cuts right off because there is nothing to the left of that. So you have this vertical line going going up from x equals 1 all the way up to the curve. And then you have a vertical line going from x equals 5 up to the curve over here on the right. And then you shade everything in between that. So that blue area that you see there is called the cumulative probability for our can opener having a lifespan of 5 years or less. Oh, and by the way, how we made this graph, so how did I make the graph? I highlighted all of the two columns A and B, all the way down to x equals 10. And I went to insert, and I inserted a scatter plot. And you can do the scatter plot with smooth lines, or you can do the scatter plot with smooth lines and markers. But don't just make the scatter plot. Make sure you make a smooth curve, okay? So we want a smooth curve for our graph of little f of x. And that's how I made the graph. You can see here an illustration of the cumulative probability for x equals 5, because it's all the values from 1 all the way up to 5. So that shows you a picture of what that cumulative probability is going to be. So in our next video, we're actually going to fill in the rest of this table, and then we will answer some questions about probabilities for in our can opener situation. All right. Like, subscribe, comment down below, share these videos with people if you think they'll find them useful, and I'll see you in the next video.